Hey guys, welcome to Analytics Vidya. As you all know, generative AI has literally taken the world by storm. From content to marketing, from data analysis to software development, it is literally revolutionizing almost every industry today. And a recent report by the World Economic Forum says that more than 75% of companies are looking to adopt AI tech in the next 5 years or so. So, one thing is quite clear, knowledge of AI and at least generative AI will become a must if it isn't already. And to keep you ahead of the curve, we are going to talk about our top 12 conceptual questions asked in this domain during interviews. Also, do not forget to check out our other videos that we are doing as part of this interview series for you. Find a link to those in the description part. Now, let's jump right into today's video. Alright, let's begin with the basics. Our very first question is, what is generative AI and where is it used? So generative AI refers to deep learning models that can generate high quality text, images, and other content based on the data that it was trained on. In simple words, it is a type of artificial intelligence that can generate new and original things such as text, images, or even music based on data it has been trained on. And how does it do that? Basically, it learns the underlying patterns and structures of data with the help of neural networks to generate new and original content. Now let's see what they can do. Generative AI can do a wide range of tasks, but here we'll look at the most popular applications of generative AI. First is natural language processing or NLP. Here, AI is used for various language-oriented functions such as text generation, language translation, and building chatbots that can engage in human-like conversations. The next use is content creation. Generative AI can create articles, stories, and even poetry. Nowadays, it is mostly used by content creators to assist in writing. Another popular use of generative AI is image or video generation. AI can generate very realistic images and videos. These are extremely valuable in fields like entertainment and design. Generative AI is also used in data science. Here it is used to create synthetic data for training machine learning model. And not just that, it can also analyze large datasets and give outputs. GenAI is used even in the health industry. It is used to generate medical reports, simulate disease progression, and many other things. And finally, in finance, AI algorithms can analyze financial data and execute trades at high speed. It can even detect fraudulent transactions and activities. Remember, it is a developing field and there is a new use case of GenAI emerging every new day. That's all we had on GenAI and its use cases. Now let's move on to the next question. So our next question is about how generative AI works. The GenAI models use deep learning to analyze common patterns and arrangements in large sets of data. Then they use this information to create new, convincing outputs. Deep learning is nothing but a complex process of computing that entails neural networks. And these neural networks are deeply inspired by the way our human brain processes and interprets information, and then learns from it over time. Now, let's break down the process of how generative model is trained and how it works. The first step is data collection. A substantial amount of data related to the specific task is gathered. For instance, if you want to generate text, your model needs a massive text corpus to learn from it. The next step is training. The neural network is then trained on this data. During training, the model learns the underlying patterns, structures, and relationships within this provided training data. It learns to predict the next word, characters, or even next element in a sequence. After training, the next step is generation. Once trained, the model can generate content by taking a seed input and predicting the subsequent elements to that sequence. For instance, if you give it the start of a sentence, it can complete the sentence in a coherent and contextually relevant manner. And the final step is fine tuning. The generative model can be further fine tuned for domain specific tasks to improve the quality of generated content. So, that is all about how a generative model works. Now, let's move on to our next question. All right, the next question is, what are large language models? This is one of the most common questions asked in interviews. Large language models, or LLMs as we call them, are foundational generative models that use deep learning algorithms to process and understand natural language. This means these models use deep learning techniques to gain a deep understanding of languages like English, Hindi, French, etc. They are trained on massive amounts of text data to learn patterns and relationships between words, grammar that is there in the language, and much more. With more and more training, they become so good that they can even mimic a human and have a proper conversation, generate new text, and even be grammatically correct. A good example of a large language model is OpenAI's GPT-4 model, which is the latest one in their series. Now, let's see what it can do. A LLM can perform a large number of tasks. For example, they can translate from one language to another, analyze online comments and reviews in order to figure out the sentiment, create chatbot conversations, provide data analysis, and even summarize text into paragraphs. Guys, these are quite a few examples of what LLM is capable of. Now, let's move on to the next question. Our next question is, what is the difference between generative AI and discriminative AI? First, let's look at the definitions and then we'll move on to the differences. Generative AI refers to deep learning models that can generate high quality text, images, and other content based on the data they are trained on. We have already covered this topic in detail in our very first question. Now, let's have a detailed look at discriminative AI. Discriminative AI refers to a class of models used in statistical classification, majorly for supervised machine learning. Examples include logistic regression, support vector machines, etc. These type of models are also known as conditional models since they learn the boundaries between classes or labels in a dataset. In simple words, discriminative model is used to identify, figure out, and classify things based on the information it has been provided. It's handy for tasks where we just need to make accurate predictions or classifications, like identifying spam emails in your inbox. That's all about discriminative AI. Let's have a look at how it is different from generative models now. All right, so now moving on to the differences. In this particular table, we have documented the key differences between generative models and discriminative models across these five categories: purpose, use case, common examples, training focus, and example tasks. You may pause this video here and go through this table. Now let's move on to the next question. All right, our next question asks about naming a few of the top Gen AI models. Post 2018, there was a surge of generative models which could do multiple tasks. Let's look at them one by one. First is GPT-4 model, which powers the paid version of ChatGPT as of September 2023. GPT-4 was developed by a company called OpenAI and is one of the most remarkable among generative AI models. With billions of parameters, it has demonstrated remarkable text generation abilities. It can answer questions, write essays, generate code, and even create conversational agents that engage users in natural language. The next is BERT. Although primarily known for its expertise in natural language understanding, BERT also shows generative capabilities. It excels in tasks like text completion and summarization. It has various applications, including search engines and chatbot, and it comes from the house of Google. The third top Gen AI model is DALI. If you love generative art, DALI is a model to watch. Developed by OpenAI, again, this model can generate images from textual descriptions. It takes creativity to new heights by creating visuals based on written prompts, showing the potential of generative AI in the visual arts. Finally, we have Stable Diffusion. Released in 2022, it is a text-to-image model created by a collaboration between engineers and researchers from CompVes, Stability AI, and Lion. This is a deep learning model that utilizes diffusion processes to generate high-quality artwork from input images. Simply put, when you give a prompt to Stable Diffusion, the model is trained to generate a realistic image of something that matches your description. That is all about this question. Now let's move on to our next question. Our next question is, what is prompt engineering? But before answering that, let us understand what a prompt is. Prompt is a detailed description of desired output expected from a generative model. In simple words, a prompt is like a question or a request you give to an AI model, and the AI model then understands that prompt and generates text based on it. So it basically enables the interaction between a user and the AI model. This is an example of a prompt. For example, if you want to use a generative model to generate a creative story about a fantasy adventure, your prompt might be something like this. Write a short fantasy story about a brave kid on a quest to rescue a captured dragon. Now, let's focus on the prompt engineering part. Prompt engineering is a technique for developing and optimizing prompts to efficiently use large language models for a wide variety of applications and research topics. It means giving your AI model the specific instructions of what to do by using the right words and details in your question or request. This helps the computer understand your needs better and give you a more accurate and coherent response. This also brings out what a LLM can actually do and what it cannot do. Someone with a great prompt engineering skill can help understand the actual capabilities and limitations of LLMs and get the maximum out of the models. Now, let's move on to the next question. In the previous question, we saw what a prompt is and we also understood what prompt engineering is. In this question, we'll look at four different types of prompt engineering, which are zero-shot prompting, few-shot prompting, chain of thought prompting, and finally, self-consistency prompting. Let's discuss them one by one. First is zero-shot prompting. It is a prompting technique that involves generating text without any training on the specific task at hand. Instead, the generative AI system uses a pre-existing language model trained on diverse tasks to generate text for a new task without additional training or fine-tuning. And if you think about it, this has a huge benefit. Zero-shot prompting allows for quick and easy adaptation to new tasks without requiring large amounts of task-specific training data. This is what it looks like. The next is few-shot prompting. Few-shot prompting is a technique in which a model is trained to perform a specific task with limited or few training example, hence the name few-shot prompting. In few-shot learning, the model is fine-tuned on a smaller dataset of examples, often referred to as a shot. This is done to learn the underlying patterns and rules of the task. The model is then tested on a separate dataset called the query set to evaluate its performance. Few-shot prompting can be helpful when the data available for training is limited or costly to obtain. This is what few-shot prompting looks like. The next is chain of thought prompting or COT prompting. This allows the model to achieve complex reasoning through middle reasoning steps. What do I mean by that? At its core, chain of thought prompting is about guiding the LLM to think step by step rather than just giving a direct output. This is achieved by providing the model with a few short examples that outline the reasoning process. The model is then expected to follow a similar chain of thoughts while answering the prompt. This is what a chain of thought prompting looks like. All right, finally, we have self-consistency prompting. This basically builds on chain of thought prompting. Self-consistency aims to replace the naive, greedy decoding used in chain of thought prompting. Just imagine you are trying to write a story one sentence at a time, and each sentence is based on the previous one that you may have written. The way you are doing it right now is to write the next sentence without really thinking too much about how it fits with the previous one. That's what we mean by naive, greedy decoding. Now, self-consistency is like a smarter way to do this. It means that when you write each new sentence, you are paying more attention to make sure it fits well with what you have written before. It's like checking if your new sentence makes sense and matches the story's tone and style. Self-consistency involves providing the AI model with multiple reasoning paths or diverse perspectives and then selecting the most consistent and coherent answer among the generated responses. This technique not only helps to reduce biases in the AI's responses, but also encourages it to consider various viewpoints before arriving at the conclusion. So that's all about types of prompting. If you guys have any doubts till now, let us know in the comment section below and we'll get back to you. At this point, let's move on to our next question. This is a pretty straightforward question. What are model parameters? Model parameters are properties of training data that a model will learn during the learning process. For example, in the case of deep learning, it is weights and biases. Basically, they are like settings or configurations that the model uses to make predictions or perform tasks. Parameter is often used as a measure of how well a model is performing. For example, ChatGPT 1 was trained on 117 million parameters, while ChatGPT 2 was trained on 1.5 billion parameters, and ChatGPT 3 was trained on a whopping 175 billion parameters. All right, let's move on to the next question. This is another very common question in this domain, which is explain the concepts of GANs or generative adversarial networks. So, generative adversarial network is an approach to generative modeling that makes a new set of data based on training data that looks similar to it. It involves training two neural networks, a generator and then a discriminator. Now, let's see what these neural networks do. The generator network takes a random input and generates samples such as images, text, or audio that is very close to the training data it was trained on. The goal of the generator is to produce samples that are almost identical from real data. The discriminator network, on the other hand, tries to distinguish between real and generated samples. This network is trained with the real samples from the training data and generated samples from the generator. The discriminator's goal is to correctly classify real data as real and generated data as fake. This training process is known as adversarial, and through this adversarial process, the networks compete and learns from each other. At the end of this training, the generator is now capable of generating high quality images, so much so that they are difficult for the discriminator to distinguish from real data. GANs have been used to generate realistic images like deepfakes, text, enhancing low resolution images, and much more. Fun fact, you can check this website out where you can see images of humans who do not exist. A very interesting application of GAN. Now let's move on to the next question. All right, our next question asks about the concept of variational autoencoders or VAEs. So variational autoencoders are generative models in which an encoder learns to map input data to a low dimensional latent space, and a decoder reconstructs the input data from the latent representation. To understand this, let's understand how an autoencoder functions. Imagine a photographer taking a high resolution photo of a location and then making a low resolution thumbnail of that photo to comprehend this better. The thumbnail may not have as much detail as the original photo, but it still provides an excellent depiction of the situation. Similarly, autoencoders compress a high dimensional dataset into a lower dimensional representation. Now, VAEs take the concept of autoencoders a step further. In addition to learning how to compress data, they also learn how to generate new samples that are similar to the training data. This means they can create variations or newer versions of the input data. In VAEs, the encoder translates the input data to a lower dimensional representation, while the decoder converts the lower dimensional representation back to the original input space. This is a pictorial representation of a VAE. Now, let's see what VAEs are used for. VAEs provide a framework for learning meaningful and continuous latent representations, allowing for controlled and structured generation in generative AI. This means they are primarily used for generative tasks such as generating new data that is similar to existing data. So that is all about VAEs. Now let's move on to our second last question. All right, this question is about how you can use reinforcement learning to generative AI. Okay, first let us look at what reinforcement learning is. Reinforcement learning is a part of machine learning where agents, in this case a machine learning model, are self-trained on reward and punishment mechanisms. It's about taking the best possible action or path to gain maximum rewards and minimum punishment through observations in a specific situation. In simple words, the ML model tries different actions, gets rewarded for good actions, and learns to do more of those actions that lead to higher rewards. Basically, it is inspired by how we humans or animals learn through trial and error. Now, let's see how this is applied to generative AI. Reinforcement learning, including techniques like reinforcement learning from human feedback or RLHF, guides the learning process of generative AI models through reward and punishments. In RLHF, feedback from human is given to the AI model, and the generator receives feedback on the quality and usefulness of generated samples. This helps to make better decisions, enhance the diversity, quality, and relevance of outputs of generative AI systems. RLHF combines expert demonstrations and reinforcement learning algorithms to refine the generator's output again and again based on feedback. This results in improved performance. I hope this is clear to you guys now. Now let's move on to our final question. The last question focuses on what are the limitations of generative AI. There is no doubt that generative AI is revolutionary, but there are quite a few limitations to it right now. And now we'll discuss them one by one. The very first one is biasness. The AI is trained on vast amounts of text data, and this data could be biased towards a specific race, gender, or some sensitive issues. And when AI is trained on such biased content, it will further create content that contains the bias. This becomes a huge problem as AI will spread biases that have existed in our society before. Next limitation is privacy concerns. Generative AI can be used to create deepfake content. This includes fake images and videos, and this can affect an individual's privacy and reputation. Not just that, generative AI can also lead to spread of misinformation. GenAI can create realistic looking text and media which may not be true. This fake news has the potential for spreading misinformation among people. GenAI can also be used to forge identities, making it a potential tool for identity theft and fraud. Moreover, generative AI can be used to create deceptive content by someone with ill intent. Things such as fake reviews, emails, or social media posts with the intent to deceive or defraud can be created easily with GenAI. GenAI also leads to legal and copyright issues. Determining the legal ownership and copyright of generated content by AI can be tough. So, this can lead to legal disputes and challenges. The next is psychological impact. The use of GenAI is creating content for entertainment or social interaction may have an impact on human psychology. People may not always distinguish between AI generated and human generated content and trust something that is not true. This can have an impact on humans psychologically, and which is a negative impact. The final limitation is accountability. Establishing accountability for content generated by AI is challenging. When harmful or problematic content is created, it can be unclear who should be held responsible for it. So, there you have it. That's all we had for you today. If you have any more questions, let us know in the comment section of this video and we'll get back to you with our answers. Subscribe to our channel for more interesting generative AI content. Good luck to you. Bye.